Hello, my name is Patrick Dyer. I'm a master's student here at Arkansas State University. My poster today is focused on comparing upstream and downstream water quality parameters in tributaries of the Buffalo River. So to start, the Buffalo River is relatively large, Strawler Stream Order 5, located in north central Arkansas, and it features a wide variety of recreational opportunities. Following a failed impoundment effort in the mid-20th century, the river was first to be declared a national river. It flows about 150 miles across the state before its confluence with the White River, which then has a confluence with the Mississippi River. So the 8 sites are on 4 tributaries, those being Tomahawk, Calf, Bear, and Brush Creeks, that feed the river in Searcy County, Arkansas. And each creek features an upstream, a headwater HD site, and a downstream, an outlet OT site. So my research is asking if the water quality parameters are meaningfully changing as the water flows through the sites and into the mainstream Buffalo. The project collects a wide variety of water quality parameters, but at this juncture, we're only looking at total suspended solids, which is a measurement of the filterable material in the water, turbidity, which is cloudiness, and electrical conductivity. So the data today is from about 2 years, n equals 106 of weekly sampling from November 2019 to December 2021. First, I ran a Shapiro-Wilk test on the difference between the upstream and the downstream data for each parameter to test normality. None of these differences were normally distributed. So I followed it up with a Wilcoxon sign rank test for significance. All of the conductivity and turbidity measurements, so between upstream and downstream, they were significant. That being the upstream was distinct from the downstream for all of those. And it was a bit more of a mixed bag in total suspended solids, with Brush and Bear Creeks being significantly different and Tomahawk and Calf Creeks not being significantly different. So the greatest conductivity was measured in Brush Creek, then Tomahawk Creek, then Calf Creek, and then Bear Creek. The greatest turbidity was measured in Calf Creek, followed by Brush Creek, Bear Creek, and Tomahawk Creek. And the total suspended solids followed the same trend as turbidity, with Calf Creek being the highest, followed by Brush, Bear, and Tomahawk Creeks. So moving on to discussion, I don't feel like we can use these averages or these medians to estimate yearly discharge of sediment or other contaminants, because it's just not an accurate depiction of base flow conditions or high flow conditions. And most of these data were defined by those two, causing a big positive skew as some of the particular TSS and turbidity measurements were 100 or 200 times larger than the base flow measurements. We know there's a big change in conductivity in Bear Creek from up to downstream. There's a registered municipal discharge of treated sewage water there. And this area has actually been delisted in the most current 303B impaired waters list. The fall in conductivity, turbidity, and total suspended solids within Brush Creek might be linked just to a lower flow rate, slower moving water causing less sediment to be kicked up, but it also might be linked to a lower overall groundwater constituency of the water. This is a karst system, limestone based. So we suspect if it's more overland flow, which because Brush Creek headwaters dries seasonally, we know this is a more rainfall driven creek, that might be linked to the difference in conductivity, turbidity, and total suspended solids. I'd like to thank Arkansas State University Ecotoxicology Facility researchers and staff, as well as the Arkansas Natural Resource Commission and federal EPA for supplying the grant for this project. Thank you for your time. Please have a nice day.